Okay. Okay, listen up. We're doing 3.3 Systems of Inequalities. We need to get this equation in slope-intercept form. What's slope-intercept form? Raise your hand. Nick. Y equals mx plus b. So the y is alone by itself on the right side of the equal sign. So y equals mx plus b. What do we need to do with this? Read. It's already subtract. The class is extra sassy today, huh? Y is less than or equal to 3x minus 4. This one is already in slope-intercept form. Okay? So we're going to graph this now. Right here. There's the second equation. Graph, and we're going to shade these inequalities. Do we have dotted or solid lines? Solid lines. Okay, we good? So we're going to graph these things. It's off. No, it's just me. I'm going to do it off every time just to spite you. Alright, so what was the... It was y is the 3x plus... It was minus 3x plus 4, right? What was it, less or greater? This equation. Less than or equal to, and it's y is greater than... Is this positive here? Oh, thank you. No, I had the signs backwards. Okay, and then this one was x minus 3? Okay, so let's graph those. We'll graph the top one in green and the bottom one in blue. So, where do we start to graph that top equation, Nick Nowak? Where do we start to graph this equation? -4 on the y-axis. And then what is the slope of the line, Nick? 3/1. Excellent. So where do I go? Up 3 to the right 1. Good. Up 3, right 1. And then we have a solid line, so we can just graph it with a solid line. So when we graph these things, you got to do, we're going to shade both equations. I'm going to wait until the end to shade. So we're going to graph the blue one now. So Michael, I'm not here. Aaron, how do we graph the blue one? Up 1, right 1, up 1, right 1. And then we're going to graph. Okay, so the green line is less than, so do we shade above or below the green line? Common sense, if it's less than, you would shade where? Below. Below, and the blue line we shade above, because it's greater. So below the green and above the blue is right in here. Okay, so that's your solution, right in here. You can do that, or you can color it in, whatever you want. I don't think you need to shade everything and look for the overlap in shading. I think it's just best to shade the answer. Okay, any questions on that? So if it's less than, you shade below. If it's greater than, you shade above. So always, sometimes you get confused, right? You freak out on a test. So you can double check a point. The easiest point to check is 0, 0. So let's say we check the point 0, 0 in this top equation. So I have 0 is less than or equal to 3 times 0 minus 4. So this cancels. So 0 less than -4 is 0 less than -4. Here's -4. Is 0 less than -4? No. So that means we shade that green line away from 0, 0. Okay, so that's your double check if you want to plug in a point. And then if your line goes through 0, 0, then pick 1, 1. Like the easiest possible point. 0, 0, definitely the easiest. 1, 1 would be the next easiest. And then if it goes through both those points, just pick another point. Alright, that's the first one. Next one, we got big fat story problem. Here's what you're going to write down on the story problem. We've got 70 and 20. Let's read it first. Tickets to a concert cost $70 or $20 with a student discount. Ticket sales must exceed 500,000 for the group to perform. If 20,000 seats are available, how many of each type must be sold? So how many of each type tells you where the variable goes. Here's what you're going to write down. The $70 and $20 ticket, you're going to write down ticket sales, 500,000, and then you're going to write 20,000 seats are available. And I'll give you a sec to write that down. Piecewise, we already got those for you. Since you do it with a unit circle, substitution determine the given value x for the solution to the equation. So you can find time in the unit circle this, right? Yeah. And then you got to think in terms of 5. All right, ready? We'll pre-calc. All right, are you ready? You need to write more down, or are you good? Okay, so what should x equal? $70 ticket, good. I always just do the first one that comes around. So $70 ticket, and then y equals what? $20 ticket. So we need to write two different equations. One we need to write for the amount of seats available. And then one equation we need to write with everything that deals with dollars. So do we know how many $20 or $70 tickets there are? No. So this equation is the easy one that you guys make difficult for some reason. So x plus y equals 20,000. So we don't want equals though, right? Because it says 20,000 are available. So does it have to be less or more than 20,000? Can it be 20,000? Right. So less than or equal to. Now let's just put this one in slope-intercept form because we're going to have to graph it. So how do I do that, Emma? Yeah. Subtract the x from both sides, and we get y is less than or equal to negative x plus 20,000. All right, let's write the dollar equation. So we had some $70 tickets, right, and some $20. So 70 was the x, 20 is the y. I'm going to leave a gap for the inequality. 500,000. So they want the sales to exceed 500,000. So if we want, does that mean this is less or more than 500,000? More. And it could, well, so if it exceeds 500,000, can it be equal to? Exceed would mean you have to make at least $501,000, right, or $500,001, right? So just greater. Okay. Half. Half point if you do these. $499.99. No, that's no good. No. All right, let's solve this one for y. Daniel, what's the first step?
For y, so we would
Subtract
subtract 78.
78x from both sides. Come on. So we get 20y is greater than negative 70x plus 500,000. What's the next step, Colin Crawford? Divide everything by 20. Good. So then we get y is greater than, I can just whack off the zeros here, so negative 7 halves x. I can cut these zeros off, and then I just do, of course, God forbid you say that in the high school class. 50 times. It's hot in here. Jim's dying over here. 50,000 divided by 2. What's that? 25,000. I'm slipping. All right, so we're going to put these in the graphing calculator, okay? Put these ones in the graphing calculator. So here's what we want to do. Your graphing calculator may have some stuff in the y1 and y2, so hit y equals. And your plot 1 and plot 2 may be highlighted. So that plot 1 is highlighted, that one's not. We want to turn off the plot 1, plot 2. Here's how you do it. You go up to plot 1, you hit enter, and then you go back down. So you want yours to look like that. If you don't have a calculator, y equals. And then we're going to put in the two equations. So we have negative x plus 20,000, and we have negative 7 halves x plus 25,000. Right, the x is right here in case you forgot. So we want to shade these two equations. So the negative x is less than, I'm going back, don't worry. The negative x is less than, so here's how you do it. You can either go over here and just hit enter until it switches. On my calculator, if you have the color one, you go like this. So I went over here and hit enter. And then I'm going to go over till it's shading less than, which looks like that. Right? It's shading less than this line. Okay, and then click OK. Yep, I'll do it on this one. So I just click enter, and then I can go down here to the line and just go until I hit the greater one, which is that one. Right, I'm shading greater than the line, so it looks like that. And then I want to click OK. Now, we have to adjust the window. Okay, yep. We'll just go over here and hit enter. Anybody else need help? No plot. No plot, huh? Okay. I would. So we want the top one less one and the bottom one greater. Now we have to adjust the window. So adjusting the window is kind of a pain in the neck because the numbers are so big, it makes it difficult to adjust the window. So I'm going to do the y's first. So our smallest y-intercept was 20,000, so I'm going to go 18,000. Our biggest y-intercept was 25,000, so I'm going to go 27,000. And then let's just see what that looks like. So I'm leaving these, the x min, x max at negative 10 and positive 10. And now, because I've done this problem 3 times, I know that's not going to work. But it'll show you how to figure it out, right? Because you got to figure this out. Anyone need more time with the window? Okay. So negative 10, positive 10 on x min and max, and 18,000 and 27,000 on the y min and max. You can hit graph. And you'll see that they're not going to meet for a long time. We're going to change that. So far. That's like the default. See how that is bigger than that? So if you need a really see how much bigger the minus is? Anybody else need help? Yeah. Top one was less than, so we go over to here, and so that one less than. Okay, so your graph will look like this, and you can tell the lines, Jack, you can tell the lines are nowhere close to meeting, right? It goes down just a smidge. So here's the question. We want to adjust the x min and max, so let's go 0 on the min. And how big do you think we need the max? Like how far over? How much? 1,000? All right, let's try 1,000 and see what happens. So we did 0 and 1,000 for the x max. This one's going down too. Yes. Okay. So let's just get here and then I'll help you. Let's try 2,000.
My red isn't moving. It's just staying red.
Too big. So let me show you another trick, right? You might eventually get kind of annoyed that they're not crossing. So I'm going to show you that one's close. But we want to see more of the part that overlaps. Okay? Okay, we'll figure it out. So look at this. If we hit zoom right up here, so hit zoom, and we're going to arrow up. So you hit zoom right upper middle, and now we're going to arrow up. And see where it says zoom fit? We're going to do zoom 0 and see if that works. So sometimes it works, sometimes it doesn't. It's supposed to fit the graph to the window. So now we just have to increase 2,000, right? So what do you want to increase it to? 2,500. You could try 3,000. This is 0 and 2,500. So now, right, we're over here. It's good on the x, but now we need to adjust the y, right? to include more of the part of the graph down here. So we're going to go this y min. No, not that low, because it's almost there, right? Just let's go like 16,000. I'll leave those up there. So who needed help? All right, so graph. Now we got to make sure we answer the question. You still have questions? Okay, so you have to be able to sketch this graph. Not hard. So you remember how you can show the little broken line thing right here? Because our window started at 16,000. So when you go to the graph, you can show the little broken line thing here, right? You just make a little squiggly line, and then you can start here. What did our start at again? 16,000? So you can start at 16,000 there and do a reasonable scale for here. You're going to have to sketch this graph. Okay? So this problem asked us, no, back here. It asked us show the solution on your calculator. I just want to show you how to get the solution. You already know how to do this. If we do second trace intersect, enter 3 times. So second trace is right here. So second trace intersect is number 5. And then just go enter, enter, enter. So $2,070 seats and 18,000 student seats. So this was the $70. And this is the $20 seat. So you need both those answers. So second trace intersect. Anybody need to see that again? Because we identified X and Y, right? Yeah, yeah. Okay, you good? Here's the last example. All right, I am.
Praying for you.
So we got to talk about the transformations with this absolute value function. So I'm going to talk about the +1 outside and then the +3 inside first for the transformation. So if you're one of the kids that just joined my class, you need to get a flip book so you can know all these transformations. I know you're in Bravos, so I know you guys did a little bit of this, but our class knows it better. So you got to copy this flip book. It does. Okay, the +1 is what? Now you guys got to show that you know it better. I'm like, don't leave me hanging. Come on. So that's up 1. We just did the flip book, right? And we were more specific about this. So up 1, and then this second transformation would be left 3. So let's do the 3 in front next. The vertical or horizontal? No, vertical.
I knew it.
Vertical stretch by 3. And then how about that negative in front? What's that do? Reflect X. Actually, I stole the flip book from Bravo, so. Alright, so the first 2 tell us where the vertex is. Okay, it just tells us where that vertex moves. So we're going to graph this absolute value one first. So we're going to start at the origin 0, 0. We'll do the absolute value one in blue. So it went up 1 and to the left 3. So that tells you where the vertex is. Now it reflected the V over the x-axis. So is it right side up or upside down V? Upside down. So if I look at, it only works with vertical stretch or compression. I can treat this kind of as a slope. So it's going to be 3 over 1. And then I just have to figure out, because it's upside down, I can't go up 3, right 1, because it's going to be right side up B, right? So I got to go down 3, right 1, down 3, right 1. Same thing over here. Down 3, right 1, down 3, right 1. Then I got my V. So that equation, was it dotted or solid? Dotted right here, right? This one's solid. So we're going to make this line dotted. Oh, I didn't do the line tool, but that worked out okay. Okay, so close enough. So dotted line. Now we're going to graph the line portion of the program. So that line was y is what? Was it greater or less? Greater than or equal to negative x minus 3? Minus 5. Okay, so I'm going to go down 5, 1, 2, 3, 4, 5. And I'm going to go down 1, right 1. Down 1, right 1. I could also go up 1, left 1. And that line is solid. Now we're going to do the shading last. So the absolute value graph, that was y is less than negative 3 absolute value x plus 3 plus 1. So this one we're going to graph less than. So you think about it from the vertex. So less than the vertex would be inside of the absolute value or outside the absolute value? Inside the absolute value, right? Less than is below the vertex, so we're going to shade down from the vertex. The green line was up, so we're going to shade above the green line, right? Above the green line. So what's the part where the shading overlaps? Just this little thing right here, right? Just shade that. Too much, right? Okay, so we're going to shade this little part right here. And that is it.